Hi everyone, welcome back. So this video I want to show you how to use GeoGebra Classic. This is a free software we can download to our computer, and then when you launch it, on the right hand side you see these 3 horizontal line segments, and we can pick 3D graphic and then unselect the graphics. That will give us a space, okay? And let's draw the surface on here. So we input the first one, we have the sphere, so x square plus y square plus z square equals 16. Okay, so you see we get a sphere. And then next, for the cylinder, we can also type x square plus y square equals 4. And we can change the color, so we can click setting, then we can change the color like to any color you like. Okay, then close it. So now you see this is the sphere, and we can see the sphere intersect the cylinder, and we get 2 loops. The intersections are 2 loops. One is on top, one is at the bottom. So far so good, everybody. Okay, how about the next one? Let's input z equals x square plus 2y square. Okay, so this gives us a paraboloid. And the second one, we have another cylinder, x minus 1 square plus y square equals 25. Okay, and we can also click setting and change the color of it. How about this and this one? Let's change to orange. Okay, let's see. What does that look like? Okay, so we can now zoom out. This is quite big, right? So let me zoom out more. I think maybe they have like limitations that they couldn't draw infinitely long cylinder, but you can imagine if they intersect, there will be some like ellipse curves over there. All right. So this is how to use GeoGebra to graph our surfaces and curves. Okay. Let's continue with our handout. Okay, so let me close this one. Okay, so lines in space. 2 distinct points in R3 determine a unique line. Alternately, 1 point and a direction can also determine a unique line. So we have a line here. We know 2 points can fix a line. And actually 1 point, P0, and a direction V can also help us to fix a line. So far so good, everybody? Okay, so an equation of the lines pass through the points P0, that's x0, y0, z0 in the direction of the vector v equals ABC. See, for points we use parentheses to denote. For vectors we use angle brackets to denote. Okay, So an equation for the line is let me see. Gamma of t equals gamma of 0 plus v of t. So gamma of 0 is actually p of 0. Okay, because when you plug in t is 0, gamma is gamma 0. Okay, so xyz equals x0, y0, z0 plus t times the vector abc. So when we multiply by each coordinate, we get x. The first coordinate is x0 plus at, second coordinate y0 plus bt, and then third coordinate z0 plus ct. Okay, and this is a parameterization, and we know this is the x, this is the y, this is the z. Okay, so we have x equals x0 plus at, y equals y0 plus bt, z equals z0 plus ct. We can solve for t. In order to solve for t, we move the x0 on the left and then divided by a. Here we move y0 to the left and divided by b. Here we move z0 to the left and divided by c. So now all of these are equal. So we get this is the equation for the line. Okay, so this is a parameterization. And this is the equation of lines. So far, so good. So what if they give us 2 points, P and Q? So if they give us 2 points, P and Q, let's say here we have P0. Okay, let me see. We use P0. Okay, or let's use x0, y0, z0, and let's say Q is x1, y1, z1. Then V is PQ. So we can use x1 minus x0, y1 minus y0, z1 minus z0, and then alpha of t is, so we can use the p, so x0 plus x1 minus x0 t, and then y0 plus y1 minus y0 t, and then z0 plus z1 minus z0 t. Okay, so this is what happens if we're giving 2 points. Let's continue. Find a vector parameterization for the line that passed through the point 4, 0, 8 and parallel to the vector 1, 4, minus 2. So the parameterization equals the point plus t times the vector. Okay, so the result, we assume it's going to be a vector. So that is 4 plus t times 1, so t. And then 0 plus 4 times t, so 4t. And then 8 plus t times negative 2, so 8 minus 2t. So far, so good. And here, t is from minus infinity to infinity. Or you can say t is any real number. Okay, so far so good. So the line passing through this P with the direction V. Let's continue. So let L be the line determined by the equation. Write down the parametric form of the line. Okay, so what you do is you set it up equals t. Well, then the first guy, x minus 5, you multiply both sides by 11, we get 11t. So x equals 5 plus 11t. And then we have y plus 1 both sides multiplied by -3. We get -3t. Y is minus 1 minus 3t. And then 3z plus 4 equals multiplied by 8, 8t. And then 3z equals -4 plus 8t. Now we can both sides divide by 3. So minus 4 over 3 plus 8 over 3t. So our parametric form equals x is 5 plus 11t, y is minus 1 minus 3t, z is minus 4/3, and then plus 8 over 3t. Okay, so also t is any real numbers. So far, so good. So this symbol means in or belongs to. Okay, and r is the real numbers. All right, let's continue. Okay, consider we have 2 points, 2, 1, -7, and 0, 3, 8. Parameterize the line passing through A and B. So we talk about we can pick any points to be our starting point P, and then the direction we can just pick AB. So what is AB? We use the B coordinates minus, okay, let me do it slowly. So 0, 3, 8, find terminal point minus the initial point. So 0 minus 2 is -2, 3 minus 1, 2. 8 minus -7, so 8 plus 7, 15. Okay, so our parameterization is we can pick any points. Let's pick the point A, so 2, 1 minus 7 plus t times this vector minus 2 to 15. Okay, so don't forget when you work on the examples, feel free to stop the video and try the problem first. And then after you're done, you can continue to play the videos and check your answers. Okay, so here we have 2 minus 2t, 1 plus 2t, minus 7 plus 15t, and t is any real numbers. Okay, part B, parameterize the ray half line that starts at A, points towards B. So it's a ray that starts at A, points toward B. Okay, so in this case, it's gonna be the same formula for the parameterization. The difference is the t we pick here. So let me ask you, if when t is 0, what do you get? When t is 0, we plug in t is 0, then we get 2, 1, minus 7, right? When t is 1, what do you get? When t is 1, you get 2 minus 2 is 0, 1 plus 2 is 3, and then that one is 8. So when t is 0, we arrive at the point A. When t equals 1, we arrive at the point B. So then for the ray, we require t to be greater equals 0. So that's why the next part, parameterize the line segments starting at A and ends at B, is the same formula, but now my t is from 0 to 1. Okay, because we check at point B, that corresponds to t equals 1. Okay, so the line segment from A to B is just, we restricted t from 0 to 1. Alright, let's continue. Example, parameterize the line segment that starts at A1, A2, A3, and ends at B1, B2, B3. Well, this formula is very similar to what we have before, right? First, figure out the direction is AB, so we can use B1 minus A1, B2 minus A2, B3 minus A3. And then we can pick any point. Usually we pick the first point. So gamma of t is, our first point is A1, A2, A3 plus t times our vector. Okay, so that equals A1 plus B1 minus A1t, A2 plus B2 minus A2t, and then A3 plus B3 minus A3t. So far, so good, everybody. Next example. In three-dimensional space, it is possible for two lines to either intersect neither intersect nor parallel. This occurs when the lines lie and the lines in different planes and have direction vector that are not parallel, and the lines are said to be skew. Okay, lines in different planes. Okay, so in each part, determine if the given lines are parallel, if they intersect, or they are skew, okay? If they do not intersect, if they do intersect, give the points of intersection. So we can have intersect, okay, or parallel, or skew. Well, skew, you have one line, and then I'm gonna do this. So you see, so they one line, so this is on top of the other line. Okay. All right. So what is special about them? Well, intersect. What is intersect? So intersect means you're gonna have a system of equations, and you can get a solution for it. Right? We solve the system of equations and we get a solution for it. Well, parallels means, well, if we have a system of equations, we don't have a solution because they don't intersect. And then what's special about parallel? Let's say line 1, we have the vector v1 in the direction, and then line 2, we have the vector v2. Then v1 must be parallel to v2. So which means one of them is the scalar multiple of the other. So this is parallel. How about skew? Well, skew means, of course, they don't intersect, so this guy has no solution. And furthermore, the v1 is not parallel to v2, so v1 is not a constant multiple of v2. So far, so good? Okay. And usually check whether they are parallel is easier than solving the system of equation. So we first check whether they are parallel. If yes, then they're parallel. If no, then we solve the system of linear equations. Do we have a solution? If yes, then that is their intersection points. If no, then the lines are skew. Okay, everybody? So let's start. Let me use a different color so you can see the common rules, and then now is when we solve it. Okay. First one. So let's look at the first line. Okay, so how do we figure out a point? So from a line, the point corresponds to the constant term. Okay, so for line 1, we know it passed through a point. That's a constant term, so 8, 2, minus 2. And we can also find, this is vectors. Okay, sorry, I forgot. So we also can find the vector. The vector in this case is the coefficient of t. So the coefficient of t, which is minus 2, 4, and 5. So far so good, everybody. How about line 2? Well, line 2, so in order to know whether they're parallel or not, we don't need to find the point. We only need to know the direction. So just look at the coefficients of t. So this is coefficients of the t. Okay, so V2 is 6s. Okay, so 6, and then minus 12, and then minus 15. Are they multiple of each other? Ooh, yes. V2 is actually negative 3 times V1. Good. So that's why we say L1 is parallel to L2. Okay, so that's A. Now let's look at B. B, let's see. What is V1? V1, the coefficient of t is 1, 6, minus 7. And how about V2? V2 is the coefficient of s. Well, that is 2, minus 4, and 1. Are they constant multiple of each other? Let's see, 1 times 2 is 2, but 6 times 2 is not minus 4. So they are not constant multiple of each other. So they don't parallel, okay? So V1 is not k times V2. So they're not parallel. Then what do is we want to solve the system of equations. Okay, which means we set the x equal, the y equal, and the z equals. We set the x equals, we get minus 3 plus t equals 9 plus 2s. And then next we have minus 4. We set the y equals, so minus 4 plus 60 equals 3 minus 4s. Last we set the z equals, so 2 minus 70 equals 5 plus s. So here we have 3 equations and we have 2 unknowns. Okay, so we're able to solve it. Let's see. Let me change it in the format so the s and the t is on the left, the constant is on the right hand side. So the first equation, I move the 2s on the left, I move the negative 3 on the other side, it becomes 9 plus 3, which is 12. And then second equation, I have 6t and I move the s on the left, so I get plus 4s, and I move the negative 4 to the other side, it becomes 7. Next, we move the s on the left, then we have minus 70 minus s, 5 minus 2 is 3. So far so good. So how do we solve this system of equation? Let's see. I might need more space because I still have part C. Okay, so let me see. Okay, so let's continue. We can use elimination method. Let's try to eliminate s. Okay, so we can use. Let's use the first equation times 2. Then we have 2t minus 4s equals 24. actually there are a lot of ways to solve the system of equation, right? So two equations can already help us to solve the unknown, and then we can plug in the third equation and see whether it holds. If it holds, then that solution is the solution. If we get s and t, we plug in to the third equation and it does not hold, it means there is no solution. Okay, so from the first equation, we get the 2t minus 4s equals 24. Then we can use equation 2 plus equation 4. We get how many t? 8t, s cancel, and then 7 plus 24 is 31. T equals 31 over 8. Alright, what is next? Well, next we can then plug in 1 to find the s, right? So we have 31 over 8 minus 2s equals 12. So 2s equals, so we move the 2s on the right, we get 2x. And then that is 31 over 8 minus 12. Well, that is, let's see, what is 8 times 12? 8 times 12 is 96. 31 minus 96 is negative 65, right? So now we have the s is then negative 65 over 16, right? Now, okay, we get the t, we get the s. Let's plug in 3 and see whether it holds. Minus 7t, so minus 7 times 31 over 8 minus negative become positive, 65 over 8. Does that equals 3? Okay, so let's see, 7 times 31 equals 217. Okay, so 217 with 65 minus 217 is negative 152 over 8 on the left. Is that equal to 3? No. That's why no solution. The lines are askew. Okay? Next, C. Okay. Let's figure out the vector. Okay, the direction first. We have 2, 9, 35. And second one, we have minus 4, 3, and minus 7. So let's see. Well, we can see V1, let's try 2 times negative 2 is minus 4. But 9 times negative 2 will give us negative 18, which is not 3. So we know V1 is not a constant multiple times V2. So they are not parallel. Okay. Next, we solve the system of equation. Let me use a different color here. Okay, because it's so close to each other. So let me use a different color so you can see the difference. Okay. Is it allowing? It doesn't allow me to change color. It's okay. Then we can continue. Let me put a line here. Okay, so let's solve the system. We said that x equals, give us 3 plus 2t equals 2 minus 4s. We said the y equals, give us negative 2 plus 9t equals negative 1 plus 3s. We said the z equals, we have minus 6 plus 35t equals minus 7 minus 7s. Alright, so now let's see first equation, second equation, and third one. let's change it a little bit. Okay, let's move the s and t on the left hand side. We get 2t plus 4s equals 2 minus 3 is minus 1. Next we have 9t minus 3s equals negative 1 plus 2 is 1. And then we have 35t plus 7s equals negative 7 plus 6 minus 1. Okay. What do we do? Well, looks like the numbers on S, the coefficient on S are easier. So we call this is equation 1, equation 2, equation 3. Let's use equation 1 and equation 2 to help us to solve S and T. So equation 1 we can multiply by 3 because the least common multiple is 12 for the coefficient of S. So multiply by 3, we have 6t plus 12s equals minus 3. Second equation times 4 give us 36t minus 12s equals 4. Now we can, this is equation 4, 5. We can add them. As cancel, we have 42t equals 1. So t equals 1 over 42. Then we can plug in either equation 1 or equation 2. So let's plug in 1. Then we have 2 times t, so 1 over 21 plus 4s equals minus 1. 4s equals minus 1 minus 1 over 21. So that's minus 22 over 21. S is minus 20. So we both sides divided by 4. 22 divided by 4, we can cancel the 2. Then we have 11. But there's a 2 left in the denominator. So we get minus 11 over 42. So we still have equation 3. So now we solve S and T. Let's plug in equation 3 to see whether it holds. So 35t is 42 plus 7 times negative 11 over 42. Is that equals to minus 1? Okay. So the common factor is 7. We can divide it by that. This is the same as 5 over 6 minus 11 over 6. Well, is that equals to minus 1? Well, 5 minus 11 is minus 6. And that's true. Yes. So equation 3 is satisfied. So which means we actually get the solution. So they intersect. The lines intersect. And the intersection point is okay. So what is the intersection point? The intersection point is not S and T. Is you plug in your let's say T is 1 over 42, right? So you plug in the line equations. So x is 3 plus 2t. Okay. I don't have enough space here. So okay. So S is 3 plus 2t, but 2t will give us 1 over 21. And then y is minus 2 plus 9 over 42. And z is minus 6 plus 35 over 42. That's the same as 5 over 6. Okay, what are these points? Well, the first point is the same as 3 times 21 is 63. 63 plus 1, 64 over 21. And then negative 2 times 42 is 84. So minus 84 plus 9 is minus 75 over 42. And then 6 times 6 is 36. 5 minus 36. Okay, so what is 5 minus 36? Is negative 31 over 6. So far, so good, everybody. Let me put the negative here so that you can see it better. Okay, so this is our intersection points. So far, so good, everybody. Very good. Okay, let me box it. So this is the intersection point. Now we have seen all three cases. We can have the lines parallel, we can have them skew, and we can have them intersect. Let's continue in the next video. See you soon!